Thank you. Our first speaker will be Ibrahim Halil Kirsan, and his topic is critical mineral needs and Turkey's mining perspective in light of energy transition and digitalization. Please go.
Distinguished participants, good morning. I would like to thank Artur in particular, as well as everyone who took part in the organization, for their invitation to the MINEX 2026 Ankara exhibition. Holding such a meeting in Turkey's capital, Ankara, is truly meaningful. As you know, this event, this forum, is organized in countries along the Middle Corridor. In about 15 minutes, I will highlight this position of Türkiye, which is located at a strategic point, from a mining perspective. I will give a presentation on its position, its strategic significance, the need for critical minerals in light of the energy transition and digitalization, as well as Turkey's mining potential and mining perspective. As I begin my speech, I greet all of you once again with my highest regards. As you all know, when we look at the stages of the energy transformation and energy transition in the world, particularly the period that began in Europe with the Industrial Revolution, and the 200-year reign of coal, followed by the introduction of oil in the 20th century, the introduction of natural gas after the 1950s, and looking at the point we have reached in the last 20 years, especially regarding renewable energy, and plans for the transition to clean energy, as seen on the slide, a massive change and transformation is underway. Despite all these developments, yes, there is a transition to clean, green energy, but coal is still heavily used across the world. When we look at the world map, we clearly see the distribution of energy resources by country. Asian countries like China and India continue to use coal heavily. Likewise, we see the Middle East region, where oil and natural gas are widely used. We see countries that are rich in hydro resources and water sources like Canada. However, despite all these developments, the share of coal and fossil resources has not yet dropped to the desired levels. Particularly in Asian countries, China, India, South Africa, and countries like Australia, intensive coal production and consumption continue. When we look at the share of resources in global electricity generation, comparing 2023 and 2024 shows that the share of coal decreased from 35.4% to 35%. The final figure for 2025 is around 34%. Therefore, 1/3 of global electricity generation is still supplied by coal production. In other words, what I mean to express is that in the upcoming period, a system based on fossil resources, meaning baseload sources, will continue until the share of resources from renewable energy increases. Again, when we look at the resource shares between 2010 and 2030, particularly electricity generation forecasts, while the shares of solar and wind are increasing, coal production still continues. Now, when we look at sustainable development scenarios, particularly the forecasts of the International Energy Agency, over the next 20 years, by the year 2040, the demand for critical minerals will increase fourfold, according to the Sustainable Development Scenario, and exactly sixfold according to the Net Zero Emissions Scenario. Specifically, the need for critical minerals used in batteries, such as lithium, cobalt, and graphite, is shown on the slide. The need for these battery elements in particular, reaching 20 to 40 times the current levels, will clearly increase. Furthermore, parallel to this need, production shares between 1960 and 2004 are shown. But the point I want to draw your attention to is that there have been significant increases in production. especially over the last 5 to 10 years. With the transition to clean energy, since the demand for components needed by digitalization and the aerospace industry has risen, production has increased accordingly. Looking closely here, we see very significant increases in lithium and cobalt over the last 5 to 10 years. Here, regarding the demand for critical minerals, we clearly see to what extent and how much critical mineral demand is required for solar energy panels, wind turbines, and other hydro resources. Again, when we look at the critical minerals required for clean energy, the need per megawatt for copper, zinc, and lead is clearly displayed on the slide. Here, looking at the global demand for critical minerals between 2023 and 2050, copper plays a leading role. It is predicted that the need for copper will increase significantly. Its differentiation from iron, for instance, iron is also a continuously used commodity. However, because a large portion of iron demand is met from scrap metal, and because copper does not have the same amount of supply, resulting in a decrease in reserves and resources, I especially want to highlight this distinction. Likewise, the projection for the demand for other minerals up to the year 2050 is shown on the slide. We also clearly see the mineral demand for electric vehicles. Here, batteries come to the forefront again. I should also mention that the need for graphite, lithium, and cobalt required for batteries plays a leading role. However, it is not very feasible to proceed with a system based solely on raw ore. Recycling must certainly support this with certain shares. It is estimated that with innovations in recycling, the total requirement can be reduced by 10%. Furthermore, when we look at the country monopolies over underground resources and bringing production online, resources are distributed among certain nations, but the refining monopoly is clearly visible in China. China's dominant role in lithium, cobalt, nickel, and rare earth elements is clearly observed. Again, China's blatant superiority in the refining of critical mineral production applies to 20 different elements, excluding nickel. Indonesia holds a monopoly there. From gallium to many rare earth elements and various minerals, China has an obvious superiority. As I mentioned earlier, we clearly observe that China's share plays a dominant role in the graphite and rare earth element requirements for batteries, solar panels, and wind turbines. You can also see the U.S. net import reliance on critical minerals on the slide. I included this specifically to give you an idea. It clearly shows that the U.S. is, colloquially speaking, completely tied to China for the critical minerals it needs. And here, I must point out that when China hits the brakes, the U.S. and European Union countries reach a standstill. According to a calculation, if China turns off the ignition and bans exports, forecasts and projections show that European Union countries and the U.S. would suffer an annual loss of approximately $3.5 trillion. There is a clear dependence on China. When we look at China's mining investments in other countries, it invests and acquires licenses across many regions of the world, securing the supply dimension. Since it also holds the refining monopoly, we observe this very clearly. So behind these trade wars, this dependence on China is clearly visible. On the left side of the slide, you see the world's largest economies. It shows the U.S. clearly in first place. China is in second place. However, according to purchasing power parity, China and India have already surpassed the U.S. In other words, there is a projection that within the next few years, this general ranking will change, and China will overtake the U.S. Behind those trade wars that started with the first Trump term lies the need for critical minerals and rare earth elements, and it is clearly visible that this forms the backdrop of the trade war. This slide clearly displays the distribution of critical minerals by country across the world. In fact, they exist in all geographies. However, mineralization and deposits are more distinctly concentrated in the Asian geography. Naturally, this places the Asian geography, and specifically China, in a dominant role. When we look at the production of critical minerals by country, there is a significant increase in production originating from the Asian geography, particularly China. Likewise, there is serious critical mineral production in the American geography, the continent, Latin American countries, and South African countries. We can see the European Union's strategic partnerships for raw material supply on the slide. The European Union fell a bit behind on this issue. To close this gap, it is working intensively to secure its mineral supply by cooperating with all regions. When we look at the countries that hold sway globally, yes, nations like Canada, South Africa, Australia, and China are prominent. However, continent-wise, we need to point out both Latin America and the African continent. We see that critical minerals are heavily localized across both continents. Another issue I want to draw your attention to is that Argentina, Bolivia, and Chile are referred to as the Lithium Triangle, and there is an intensive mining war playing out in the background here. Particularly in recent years, in the elections held in Latin American countries over the last few years, the loss by the left wing and the victory of right-wing politicians, the loss by the left and victory of the right, is interpreted in political commentaries as being driven by a desire to counterbalance China and an instinct to possess critical minerals, primarily lithium. As you know, many countries have started publishing their critical mineral lists. On the slide, you see the critical mineral lists of the European Union countries, the US, and Japan. In the common intersection set, there are nearly 20 minerals. In other words, critical minerals hold a shared value for many countries. On the next slide, you see Canada's critical mineral list. Currently, Canada has a list of over 30 critical minerals. Turkey's critical mineral list was published in 2025 by the Ministry of Energy and Natural Resources. As you can see on the slide, it is clearly defined in our country as a list of high-importance critical minerals, primary critical minerals, and potential critical minerals, totaling over 30 minerals. To save time, I need to move forward a bit quickly. We also need to look at Turkey's mining potential. Actually, when we place the minerals on a sheet of A4 paper, the map of Turkey emerges directly. This means that Turkey is called Asia Minor because of its serious mineral diversity and its capacity to host minerals. The reason is that it contains nearly all the minerals and metals found across an entire continent. We are in the top 8 in terms of diversity. We rank 22nd in mining production by volume and 28th by value. From metallic minerals to industrial raw materials and energy raw materials, we host almost every type of mineral. When we look at our globally significant minerals, we rank first in the world in boron. We are in the top 5 in marble. We are in the top 5 in chrome. We are in the top 5 in pumice production. As I said, we have a clear superiority in metallic minerals, industrial raw materials, and energy raw materials. I have displayed Turkey's metallic mineral reserves to give you an idea. I use the publications of the Homeland Mining Development Foundation as a source. We possess metallic mineral reserves ranging from gold to uranium across many areas. Likewise, we have a distinct superiority in industrial raw materials. In feldspar, we are at a point to enter the top 3 globally. We host many industrial raw materials. When we look at some of Turkey's critical mineral reserves, We have a serious lithium potential from the boron fields operated by Eti Maden. Likewise, we host many minerals such as nickel, cobalt, manganese, graphite, and rare earth elements. Therefore, looking at it from this perspective, our country holds a major advantage in terms of mineral potential and diversity. To give you an idea, there is some information on the slide regarding rare earth elements in our Eskişehir Beylikova site. With 694 million tons, it appears as the second largest potential site after China's Bayan Obo site on the Mongolian border. Since laboratory-scale pilot studies concluded successfully, work is currently continuing at a pilot scale. The pilot plant operations are ongoing. Approximately 125,000 meters of drilling have been carried out at 310 locations on the site, and it contains roughly 3% rare earth elements. With a reserve of about 12.5 million tons, it is at a level to enter global rankings. However, since this site has not yet been tied to an international reporting standard, it has not officially entered global literature. Nevertheless, our state and the relevant institutions are conducting extensive work to bring this site into production. In a few moments, our colleague from TENMAC will perhaps provide more detailed and comprehensive information. Furthermore, looking at rare earth reserve countries and their production, China obviously plays a leading role. China alone produces 270,000 tons, or 70%, of the world's approximately 400,000 tons of rare earth element production. When we look at reserves, we see which country holds how much reserve on the slide, from Brazil to India and others. These are the production figures for rare earth elements that I just mentioned. China has a distinct advantage, and here you see the rare earth element producers. Nearly 20 companies hold a global monopoly, and they are predominantly Chinese firms. To wrap up, where is the global mining industry heading? Especially with the discourse that caught the public's attention in 2025, starting with Trump's dispute with Zelensky, a massive spike occurred in Google searches. In 2025, a 91% explosion was experienced in Google search trends. In other words, the world is curious. What is a critical mineral? What is a rare earth element? I included this graph for its striking impact. As my final slide, I would like to say a few things about our country's mining perspective and strategy. As I mentioned earlier, our country has a strategic position. It is located on the middle corridor. It sits at an extremely critical point in terms of mineral diversity, potential, and geographic location. This makes our country seriously attractive. However, I must emphasize that it is impossible to produce these minerals without a sustainable and responsible mining approach. We absolutely must prioritize the environment, human health, and occupational health and safety. And rather than producing and selling them as raw ore or concentrates, we need to evaluate our country's mineral potential by enriching them with advanced technology and converting them into final products. The critical mineral list has been published, but this is not enough. These lists need to be updated periodically to remain compatible with contemporary conditions. To achieve all this, a national mining strategy is required. For this purpose, we have a proposal to establish a critical minerals presidency. I published this last year and shared it, and it found global resonance. Therefore, with the participation of relevant institutions, the Ministry of Energy, the Ministry of Industry and Technology, and the Ministry of National Defense, because the need for these critical minerals has surpassed the scope of a single ministry, and now concerns 3 or perhaps more ministries. Consequently, establishing a critical minerals presidency and institute through a top-down restructuring, determining legal regulations accordingly, and clarifying the strategy in that manner is of paramount importance. Within this framework, I conclude my presentation. Thank you all for listening. I offer my respects.